Welcome to week 12 of Psych 4981, The History of Psychology. We have a two-part lecture today. One part is going to focus on Steven Pinker's book, The Blank Slate, and we're also going to have a review of some of his ideas about gender differences. And then in part two, I'll be talking about the current crisis in psychology, which will probably carry over into week 13's lecture. So let's start with this living psychologist. He's one of the few people we've covered in this course who's actually alive and well. Steven Pinker, born in 1954. He was born in Montreal, Canada. His father was a lawyer and his mother was a school counselor and eventually became the school vice principal of her school. Steven Pinker himself has several siblings, and his siblings have all actually done very well. He notably has a sister who actually is a professor who's written books on topics that are related to psychology as well. But he himself went to McGill University in Montreal, did his undergraduate psychology there, and then received a PhD in 1979 from Harvard in cognitive psychology. His advisor was Stephen Coslin, a noted cognitive psychologist there. From 1982 to 2003, he was an academic professor at Massachusetts Institute of Technology in Boston. And then since 2003, he has been a professor at Harvard University, where he is today. His primary research is in visual cognition, psycholinguistics, and evolutionary psychology. Now, he's written several books, and these books that I've listed here are all really meant for the mass market. So that is, and they're not, your tedious sort of academic books. These are all books that have become bestsellers, have done very well. I would recommend all of them. He's a very good writer, and they're all very interesting books. But we have The Language Instinct in 1994, How the Mind Works in 1997, The Blank Slate, which I'm going to be talking about in a moment, which was published in 2002, The Better Angels of Our Nature in 2011, and more recently, he published Enlightenment Now, The Case for Reason, Science, Humanism, and Progress. Now, the book that I have pictured here, The Blank Slate, was a book that I originally had students in this course read, and it was part of the reading list that would normally be taught in this course. But in recent years, I've actually got rid of this book on the reading list just because it became too much work for the students. It's actually a pretty long book. It's several hundred pages long, and trying to squeeze this into a 13-week semester with the other books that I had led to a lot of complaints just because of the work. I still think, though, it's a very important book, and I recommend it to anybody seeing this lecture that when you have a chance, put it on your to-be-read list. The Blank Slate is an important book, probably one of the most important books in psychology published in the last 25 years. It's generated a lot of controversy, so if you want to be up on controversies, it's a good reason to read the book. It also has a good review of a lot of the themes that we have covered in this course. And in fact, you'll remember at the very first lecture, I talked about this book there because I said there'd be these repeated themes in this course as we looked over the history of psychology. And from Pinker's point of view, he believes that modern psychology is challenged by three dogmas that determine our view of human nature. And so these are these three dogmas that I said would be also repeated themes in this course. And one of them was the blank slate itself, this notion of the idea that we're born with just a blank slate in terms of what we know about the world. And it's through empiricism, through our experience of the world, that we learn everything we need to know. We learn our speech this way. We learn how to think. We learn how to behave. Everything comes from direct experience through our senses. And that's, of course, why empiricism became a major part of science as well, that science believed that in order to do it properly, we have to experience these things directly through experiments or whatever it is. This notion, he's not saying necessarily that empiricism is bad. He's just saying that the blank slate itself has been so widely adopted that this dogma is actually hurting our development of psychology and society. The second dogma that he talked about was the noble savage. This goes back several centuries now, this idea that the humans that are out there in the world that have been untouched by the rest of society represent our purest form. They're good. And so another way to think of this, the way that Pinker talks about this, is that a lot of people believe that people are born good. There's nothing about them other than goodness, and it's society that corrupts them. And so this comes again, supports the idea of the blank slate, that our natural propensity is to be good, but through learning, some individuals learn to end up doing bad things. And then thirdly, we have the ghost in the machine. And this, we talked about this back to the ancient Greeks, but you can also maybe really point to it to Descartes, who ended up creating this dualistic model that's really dominated psychology for several centuries and philosophy. And this is this notion that each of us has a soul. Sure, there may be a brain and a brain that controls our behavior and so on, but simultaneously we also have a soul. And this idea of having a soul, again, Pinker thinks of as a dogma that's causing us problems. He said that as a consequence of having these particular dogmas, having these three major notions in modern psychology, this then leads us to have four fears that permeate the way we do psychology, the way we think about policy, the way we think about organizing our communities, and so on. So this is meant to be a very broad philosophical argument in some ways about just the way humans conduct each other. And so he's saying, again, if you believe in those three themes that I just covered, then you're going to have these four fears. Let's take the first one, the fear of inequality. So the idea here is that he's saying that if you really believe in the blank slate, you also then will be afraid of anybody having inequality. And that means that everything has to be equal all the time. And so he says, well, just because we may not be equal, if you don't follow the blank slate and you reject it, we may find that people actually are not equal in terms of their abilities and their propensities for violence or whatever it is. That doesn't mean that policies can't treat people the same. So that is that individuals may have their own characteristics that they were born with that makes them act in a certain way or think in a certain way. He's saying that you can still have policies that treat people equally and give people individual rights. So he thinks it's not a threatening thing to believe that people are not equal in all of their abilities. That's kind of like what the blank slate says, right? Remember, some of the people like even John Watson try to say that we're such blank slate when we were born, that whether I become a criminal or I become a millionaire, it's really because of my history of what happens to me after that point of being born. Well, here Pinker is saying that you could just accept the fact that perhaps at birth people already are different. They're not equal. But that doesn't mean that you can't have policies that treat everybody equally. And so he thinks that this fear of inequality gets into the way of thinking about policy that way. The fear of imperfectibility is this idea that, perhaps we're not such good people. We're not like the noble savage, that maybe some of us are more good than others in terms of our backgrounds, our propensities. Again, not having anything to do with the blank slate, just perhaps because of genetics or an interaction with genetics in the environment. And he says here, moral progress doesn't require that the human mind be naturally free of selfish motives. It is, we could have some imperfections in us. Some of us may have more selfish motives than others. It's just that the idea is that we might also understand progress as having other motives in us that help us counteract our selfish motives. So we could work on other parts of ourselves that help us counteract the propensity to be violent, for example. And so again, recognizing that humans may differ in their motivations just from at birth doesn't mean that we can't intervene and try to find other ways of helping them with other motives to counteract their negative propensities. The fear of determinism is this idea that, what's nice about the blank slate is that it kind of tells you that, your world is open to you. Your world is your oyster. There's so many different things that can happen just depending on what path you chose. He thinks, of course, that it's more deterministic than that, and that there's actually a lot of cause of why we are, that there could be some genetic things you're born with. There was something about the circulating prenatal hormones that affected your brain at birth. And just because there are things like this, variables that could determine your behavior in later life, isn't a bad thing. You shouldn't be afraid of that. He says, responsibility for your actions doesn't require that your behavior is uncaused. That is, you don't have to say just because everything's been determined at birth or because of a head injury or whatever it was, that you're no longer responsible. He says, no, you do have responsibility. And what we could do is we could respond to people based on their behaviors with praise or blame to help shape their behavior. So this is where learning would come into play, is you could have praise and blame affecting how we deal with people who act in ways that are not acceptable to us. So determinism doesn't have to be the end all and therefore excuse responsibility. And the fear of nihilism, he says, is another fear that underlies all of these three dogmas. That is, maybe there's no meaning in life because it's all been predetermined and, you don't have any choice. And he says meaning in life doesn't require that the process that shaped the brain must have a purpose, only that the brain itself must have purposes. So he's saying, if I can go ahead and show you how your brain got to be the way it is, you shouldn't feel depressed about that. He's saying that one of the things that might have happened is that we could show maybe from evolution that your brain has evolved to have purposes, that it has different parts of it that will allow you to feel that you have a purpose, that you need to go and, do things that help your self-esteem or to help propagate the species or whatever it is. He's saying there's plenty of purposes here that could have evolved or could be part of why our brains are the way they are. So you shouldn't feel this fear of nihilism. Well, I'm going through, each of those, by the way, are covered in chapters. So what I've just done for you is give it to you in a very brief way. I'll just finally sum up this book by talking about the way that he thinks that believing in a blank slate can lead to bad outcomes for society. So he says, for example, that if we really believe in a blank slate, this could lead to totalitarian social engineering. So this is where he comes into conflict with a lot of Skinner's ideas and behaviorism, and perhaps the way Walden too talks about things. That is, that if you really are going to believe that it's all about the environment, then you go ahead and decide that then you're going to have a totalitarian social engineering where every single policy will be about rewarding positive behaviors, punishing the negative ones, so that you can go ahead and then just completely control people based on their environments. And so he thinks that erroneously believing that we're just blank slates at birth could lead to this notion that you could control society through these kind of social engineering things that are probably best exemplified in the book you read, Walden 2. He also thinks that believing in a blank slate leads to unnecessarily blaming parents when children do not turn out well, because we right now say that everything about childhood is about the fact that their parents raised them this way, when in fact there could be other factors that influence a child's outcome, again, including their genetics, their prenatal care, other things that have nothing to do with the parental upbringing. But right now, because of the blank slate, we tend to focus a lot on blaming parents when a child doesn't turn out to do the best behavior. He also says believing in a blank slate can lead to release of dangerous psychopaths who quickly commit new crimes. So he's saying, sure, we could go ahead and believe that we're going to reform people in prison with, the best kind of learning and change their outcomes of who they are through proper training. But then that negates the fact that there could be people who are just born sort of evil, that they have a psychopathic brain already at birth, and that we would then treat them and they could go ahead and fool us, and then they could be released back into society. So believing in a blank slate leads to that. And finally, the last one he argues is that the persecution and mass murder of people who are thought to have gained advantage unfairly. So if you're a blank slater, according to Pinker, you believe in equality, that everybody has the same chance, that we all have the same backgrounds, the same genetic predispositions to do things. So he's saying in history, whenever one particular group starts to do better than the rest of the groups, what can happen then is to say, well, those people are cheating because they're not following the rules. They're doing something here in our blank slate environment that's getting them ahead. And so we have to persecute them and perhaps even murder them, like you might have looked at the Holocaust as that way, as saying that certain groups that Hitler said were unfairly taking advantage of the rest of the population need to be suppressed. So it's arguing here that if you are a blank slater, you're going to be more likely to persecute people who become better off, because obviously, according to a blank slate point of view, and according to Pinker's view of the blank slate, you think that that person must have cheated somehow, or that group cheated. So I want to go ahead and just let you know that I do have a link to a video up on Blackboard for Pinker speaking about this. It's about a half an hour talk that he gave for TED, maybe 23 minutes. I didn't want to put it into the middle of this video because I think it's just a tad too long to add to this lecture. But I have the link, and if you don't have the link in front of you, you can't find it, just do a search for Pinker Blank Slate at the TED Talk, and you can see him talk about this book after it had been published a year later. One of the things that he talks about in this book is just the reception that he had for the book, like how people responded to it. As I've already noted, it was controversial. And one of the reasons why it's controversial is he really takes on psychology the way it was around 2001, 2002. That is, he believes that there are a group of psychologists who really cling to the blank slate, and it's therefore making them not consider fully scientific explanations for lots of different behaviors because they cling so much to the blank slate notion. And he sees this as really keeping us back in our field of psychology. And so in this talk, he brings up some of these criticisms that he thinks are coming from the groups that he was criticizing in the book. And so you can kind of see how he engages with that. Now, in this course, you're reading Cordelia Fine's Delusions of Gender. And it has a lot of interesting discussions, of course, about gender differences, sex differences, and what the research shows on that. While you're reading that, and given the fact that this is something we're focusing on in the last couple weeks of the course, I thought it'd also be illuminating to look at how Steven Pinker has addressed these issues about sex and gender differences. And in order to understand this, you have to get a little bit of a context of something that happened in 2005. The president of Harvard, Lawrence Summers, gave a talk to a group of people who were discussing the problem of gender inequity in representation of faculty members. And in particularly, what they were trying to understand was why there was such a huge difference between the number of men and women in fields like computer science and engineering and other STEM topics. And at this talk that he gave, he went ahead and offered 3 different hypotheses about why this might be, why we're having such a hard time here at Harvard recruiting women into those particular professions. And at the end of this discussion, he had this comment, and he said, "So my best guess to provoke you of what's behind all of this is that the largest phenomenon by far is the general clash between people's legitimate family desires and employers' current desire for high power and high intensity. That in the special case of science and engineering, there are issues of intrinsic aptitude, and particularly of the variability of aptitude, and that those considerations are reinforced by what are in fact lesser factors involving socialization and continuing discrimination. I would like nothing better than to be proved wrong, because I would like nothing better for these problems to be addressable simply by everybody understanding what they are and working very hard to address them." Now, the part that I have underlined probably was one of the comments that provoked most of the controversy at this time. And what he's trying to say here is that he thinks that perhaps there actually really are differences between men and women in terms of their aptitude and this variability of aptitude, which I'll cover in a moment, and that these are probably bigger reasons why we're not finding women in science and engineering than it would be what he calls lesser factors, including socialization and continuing discrimination. So almost immediately after he made this talk, he was confronted with controversy and people being very upset at Harvard, and particularly the other professors there, about these comments. And he was very loudly condemned by many professors across many departments at Harvard University. Here, for example, is an article that was published right around that time in the Boston Globe. You can see it says, "Summers' remarks on women draw fire. The president of Harvard University, Lawrence Summers, sparked an uproar at an academic conference Friday when he said that innate differences between men and women might be one reason fewer women succeed in science and math careers. He also questioned how much of a role discrimination plays in the dearth of female professors in science and engineering. So as I said, lots of controversy. I think within a few months there were several people calling for his resignation. There was just lots of uproar. It took several months. I mean, this became national and international news at the time that this president of Harvard had offered this as a possible explanation, that there were inherent differences between men and women, and it wasn't just about discrimination. And one of the supporters of Summers at this time, though, was the new professor who had joined psychology, and that was Steven Pinker. And Pinker had almost right from the beginning said that Summers was being considerate. He was actually considering the literature, looking at science, and perhaps there really actually were such differences between men and women. So later that year, Steven Pinker engaged in a debate with Elizabeth Spelke, another professor there, about why there wasn't greater equity in male and female professors across the disciplines in Harvard. And I have, again, put a link up for this. You can actually watch the debate. It's a really fascinating debate. You'll hear Pinker go first, and then Spelke talks, and then they engage back and forth a little bit. Now, Pinker's main argument was that he thought that such differences could be in large part due to evolved biological differences between men and women. So remember, he comes from an evolutionary psychology perspective, and so he thought that evolution actually maybe had favored some of these biological differences that caused men to be better prepared for careers in STEM subjects. I'm not going to cover Spelke's side of the argument here because I don't have the time to do that. Also because you're reading Cordelia Fine's book, and Cordelia Fine covers a lot of these same arguments that Spelke makes in greater detail in her book. But again, I want to encourage you that if you really do find this interesting, that you should go and look at the debate itself, watch it, and hear both sides. I just want you to get a flavor of Pinker, since we're not really able to cover Pinker very much by reading one of his books this semester. So these are actually some excerpts from his arguments with Spelke, and I think it does a good job of showing you how he and other people view sex differences today, and how this might translate into real-world differences in the job market, and so on. So here's some data that Pinker started up with. And what he wanted to show here was the underrepresentation of women in academia, in academic positions at elite universities. So this is around 2005. I couldn't actually find the source for this. I could just find the slide. But whatever these data are, he's trying to show how underrepresented women are in mathematics. Only 8.3% of professors in mathematics at elite universities were women. Chemistry, it's 12.1. Chemical engineering, 10.5. Physics, 6.6. Mechanical, electrical, civil engineering. Computer science, astronomy. So these are all occupations where you see very relatively few women in those occupations. And so he thinks that this is really what Lawrence Summers was trying to address, this gap. Like, how do we explain this? Why are there so few women drawn to these particular professions? And if Harvard wants to have role models of women in these professions, and they want to have good representation of men and women in every field at Harvard, how can we how can we address this? How can we understand why we're having such a problem? I wanted to give you, by the way, an update on those numbers, because like I said, that's from 2005. The closest thing I could find was this table of data that was published in 2014, and this just shows you the percentage distribution of total college graduates in the United States between ages of 25 and 34, and where they got their degrees. So this tells you among all of the people who had university degrees, and I think this is close to 8 million people or so that were in this survey, they're covered here in these data. You can see that in computer and information sciences, about 1% of all of the women who had a college degree had it in computer and information science, whereas 3.1% of the men had a degree there. Or 3.1% of college degrees were men in computer science. And similarly for engineering, you can see we have 3 times more men getting degrees in college, in engineering and engineering technologies. Biology and biomedical sciences, there's actually more women getting that in that degree, but math and statistics are relatively same. Interestingly, physical and social sciences are grouped together here. And this would include psychology, I believe, and sociology, and this is a place where you get more women. And then health studies, you can see there are more women. But if you kind of focus on those ones up at the top again, it's fitting pretty well with those data from 2005 that more men are going into those disciplines than women. And I don't think any of you will be too surprised to know that today, like for instance, if you went over to engineering, we're still going to find a preponderance of the students that are studying engineering, for instance, are men, right? So again, that's the phenomenon that Pinker and others are trying to explain. Why do we have this big gender gap in those professions? Now, Pinker offered this as a following his explanation. And again, being somebody from psychology, he used psychology research to talk about it. So I'll sum up his main points. He said that there are 6 differences between men and women that could explain this gap. He said, first of all, men on average are more likely to chase status at the expense of their families. Women give a more balanced weighting. So if there's a work versus family kind of situation, men on average are more likely to chase the work, whereas women are more likely to balance work and their families. He cites a study that is a large longitudinal study that's been going on for decades. It started in the 70s. Back in the 1970s, 1,975 youngsters who were in the 7th grade had been identified as being in the top 1% of ability in mathematics. And at that point, there was relatively equal numbers of boys and girls, I think. But anyway, they followed them up for the next few decades to see what happened to them. So the dark bars here represent the boys in that study. The white bars represent the girls. You can see by the time we get to this year, which is around 2000, that there are more men in the study than there are women. I'm not sure if that was actually what it was back in the 70s, but anyway, keep that in mind. There are more men in the study than women. And they asked them questions in 2000. So now they're in their 30s. And so keep in mind, these are all people who had very high ability in math. They weren't just everybody. It wasn't a representative population. It's just people who are select in the top 1% of ability in math. And you say to them, how much do you typically work in a week? How many hours do you put in? Keeping in mind that 40 hours a week should be like sort of the typical amount of time that people would want to work or do work. And you can see here in this sample, they're well over 40%, most of them. 40 hours a week. You can see, though, that for all of the bars, except for the lowest one, you can see that in terms of how many hours they work, men are working more per week than women. So there are more men who are picking 50 hours to 59. There are more men picking 60 to 69, more men picking over 70. And then if you ask them how many hours a week would you be willing to work, so like in an ideal situation, how much would you ideally like to be working, you can see that women, ideally, they would have many more women pick that they would like to be working less than 40 hours a week. The gap between 40 and 49 is smaller there. But then when we get to over 50 hours a week, men are more willing to work longer hours, 50 to 59, 60 to 69, and over 70 hours a week. So what Pinker is saying here is that men, for whatever reason, we haven't really fit the reason yet to explain this, but he's saying that men seem to be more likely, even when they're matched with women who have the same kinds of skills, mathematically speaking, men are more willing to take work and have that go out of hand than women are, who keep it more balanced. The second thing he says, another sex difference between men and women, is that another difference between men and women is that women are more interested in people, and men are more interested in things. And so what he's saying here is that there's something about the brains of women that make them want to be more around people, and men are just generally more interested in things. And it's because of this that this means that they're going to gravitate to slightly different directions in their choice of career. The occupation that fits best with the people end of the continuum would be things like a director of community services organizations, whereas the occupations that fit best with the things ends would be like being a physicist or a chemist or a mathematician. And so if you look at the data in terms of where the degrees going for women and for men, you can see that here the percentage of women who get a bachelor's, a master's, a doctorate, and become a professor, that you can see, I think that's professional, has increased. So we're getting more women getting advanced degrees. But then if you look at the bottom chart, you can see where they're getting those degrees. They tend to be doing them more in education and the social sciences and less so in physical sciences and engineering. So even as women come to university and seek higher degrees and spend more time then at the university to get those more advanced degrees, you can see that they're choosing to go more into education and social sciences and choosing not to go into physical sciences and engineering. So he's saying perhaps that shows us that women are more interested in occupations that involve people, leaving those occupations that are more about things for men. Another difference between men and women, he says, is that men are by far the more reckless sex, and he cites a large meta-analysis that was published in 1999 in Psychological Bulletin that involved 150 studies and 100,000 participants in 14 out of 16 categories of risk-taking that were talked about in this meta-analysis. Men were overrepresented, is that men more likely would take the risks than women on each of those categories. Now, the two categories that they weren't doing that were they were actually fairly equal, included smoking. So one of the risk categories that you find men and women taking the same amount of risk is in smoking. And he also says here two of the largest sex differences were in the risk categories of intellectual risk-taking and participation in a risky experiment. So in the meta-analysis, when you look at those studies that looked at intellectual risk-taking or participation in a risky experiment, men more likely than women chose to take risks there. So he's saying this is another piece of data that support the idea why you see these differences in academia. Then he says there are sex differences between men and women in terms of men being better at three-dimensional rotations. And so these are the kind of experiments you may have seen before, where you have to take the object on the left and figure out which one of the ones on the right is the same object. So you have to mentally rotate those blocks. And when you give these to men and women, men score higher than women by a big magnitude. And so he says this kind of cognitive skill is necessary for these fields like in engineering and maths and so on. And if women don't have the same skill as men on those tasks, that could explain why they're not attracted to STEM subjects. And another one is that he mentions that after puberty, men are better at mathematical reasoning. He cites a meta-analysis again that was published in 1990 by Hyde et al. And you can see in this study they had 254 data sets with more than 3 million participants. They found that on maths, there are no differences between boys and girls in childhood. And then, as I said, after puberty, though, you start to see a difference. And so in high school and going off to university, if you give math tests to males and females, you see a definite difference where men do better than women. And that's got an effect size of 0.3. And I have here, especially in high-end samples, so when you take people who are particularly strong students and who have a really good academic record, or excellent students otherwise, you see, again, a very big effect size that men do better than women on math tests, and that this difference, again, would translate possibly to why you don't see them then at the university in these particular subjects. And then the sixth one, and this is one that was alluded to by Lawrence Summers in his comments, is that he argues that men have greater variance on relevant traits than do women. This is known as the variability hypothesis. And you can see how this is talked about here. The idea here is that if on a particular trait, men were the green distribution and women were the blue distribution, you can see that they're both normal curves and they both have the same mean. But because men have more variability on that trait, that means that at the extreme ends, at the low side as well as the high side, there would be many more men on that trait, having that trait in great ability of it. And of course, on the opposite end, I mean, be men who don't do very well on that trait. But they would have the overall same mean. And so it's that curve on the right, those differences in the curve, that would be the explanation about why you get more men in these professions. And this idea, this variability hypothesis, is actually a pretty old one. It goes back to Darwin, who talked about it in terms of sexual selection. He proposed that just generally in the animal kingdom, that males had more variability in their traits, and this had to do with sexual selection. And so when Darwin talked about this, just generally speaking across the animal kingdom, psychologists then took this hypothesis and applied it to explaining differences between human men and women. And among some of the proponents of this hypothesis would have been Thorndike, G. Stanley Hall, and James McKean Cattell, whom we've covered in this course. So like I said, this is a pretty old hypothesis that sort of stood up over the past century. Just to give you some highlights, these are things that Pinker says support the variability hypothesis. There was a 2007 meta-analysis that found that males are more variable on most measures of quantitative and visual spatial ability. There was a 2008 analysis of test scores that looked across 41 countries that were published in Science, and they concluded that data shows a higher variance in boys and girls results on mathematics and reading tests in most developed countries, implying that gender differences in the variance of test scores are an international phenomenon. Now, I'll also mention to you that there was a 2014 review, more recently, that found that males tend to have higher variance on mathematical and verbal abilities, but females tend to have higher variances on fear and emotionality. However, these differences in the variances were really small, and the causes really not very clear. There was also a 2005 meta-analysis on Raven's progressive matrices, and they didn't find any difference in the variability of these sort of advanced progressive matrices. But they also found that males had a higher score on the mean than women. So they didn't actually have differences in the variability, but they had differences in their mean. So it goes on and on. There's lots of sort of controversy and differences going back and forth over the past century about whether or not this variability hypothesis could explain why in certain professions you have more men than women because of these because of the variability of this. I will leave it to you to look more at this. I will say, like I said, there are several people out there who have actually argued against the variability hypothesis and said that there isn't as much evidence in support of this as you might think. Well, this ends, though, Pinker's arguments about, or his explanations about why there could be these differences between men and women in terms of representation at the university. So he says, Pinker, that now the fact that these 6 gender differences exist does not mean that they are innate. This, of course, is a much more difficult issue to resolve. A necessary preamble to this discussion is that nature and nurture are not alternatives. It is possible that the explanation for a given sex difference involves some of each. The only issue is whether the contribution of biology is greater than 0. I think there are 10 kinds of evidence that the contribution of biology is greater than 0, though of course it's nowhere near 100%. So he's, in a way, setting up a straw man. He's basically saying, I don't believe in the blank slate where it's exactly 0 contribution of biology. I think that there is a greater contribution of biology here than 0, and I'm going just to use that as my only bar here to say that there is some contribution of biology that could explain these 6 gender differences. And he talks about 10 types of evidence, and I'll just very briefly tell you what these are. He says there actually are biological differences between boys and girls, and that this could explain this, that there are large differences between males and females in the levels of their sex hormones, especially prenatally in the first 6 months of their life and also at adolescence, and that there are these receptors for these hormones all over the brain, including the cerebral cortex. And so this would yield many small differences in men and women's brains, including the overall size of the brain, correcting for the body size, the degree of cortical asymmetry, the size of hypothalamic nuclei, and others. So again, these are all things that Cordelia Fine reviews in her book, and so you have a bit of more of an idea of what her perspective would be on this. He says that many of these sex differences are universal. He says the idea that there are cultures out there that somewhere in which everything is the reverse, where males don't have what we consider the female traits and females have what are the male traits, just don't exist. He says that he doesn't think of anything like that. He sees it more as there being human universals across anthropology that show that men and women have these different natures, and that generally speaking, women are generally involved in direct childcare. Competitiveness is more something you see in men, and that there's a greater range in spatial abilities by men compared to women. That these differences haven't changed much over time, and that you haven't really seen, just if you look at really precise measures in the last 75 to 100 years, there haven't been any really big changes in differences between men and women scoring on these tests, even with all of the developments in equality that have happened in the law and in many different societies. He says you just don't see these changes happening very much. That many of these differences are also seen in other mammals, so that you can find other mammals that show that male members of their species seem to do better with things like mental rotation and things that may have to do with more like mathematical abilities. That many of these differences develop early in life. And here he even talks about some of that research that Cordelia Fine goes over, that at birth, newborns show the boys that prefer physical objects, where girls are preferring faces. But I then refer you to Cordelia Fine, who sort of takes down that particular study. That there are studies there of genetic boys who were brought up as girls, and they still had tendencies to be more boy-like in their abilities on these relevant tests. That there's a lack of differential treatment by parents and teachers, and so he cites some major studies and some meta-analyses that have looked at how teachers and parents treat boys and girls when it comes to maths and science, and he argues that there really isn't much of a difference in the way parents and teachers do this. That there are prenatal sex hormones that could explain this. That is that these prenatal hormones may be making a bigger difference in later thought and behavior, and that he talks about certain conditions where that you might get, for instance, girls who are subjected more to androgens, and they end up having more male typical toy preferences, like for trucks and guns, compared to other girls who don't have this. And so he's just trying to say that he thinks that sex hormones can be another place that lead us to have these gender differences or sex differences. We have circulating sex hormones. This is, obviously where you could talk about things like testosterone and how the levels of testosterone, or even hormones that are released during women's menstrual cycles, that can play a role in men and women's mental abilities. And then he mentions imprinted X chromosomes. And this is where he talks about that there's this phenomenon called genetic imprinting, that where you can see that an X chromosome can be altered depending on whether it was passed on from one's mother or from one's father. This makes a difference in the condition called Turner syndrome, in which a child just has one X chromosome but can get it from either the mother or the father. And when she inherits an X that's specific to girls, on average, she has a better vocabulary and better social skills, and is better at reading emotions and body language and at reading faces. So he's trying to say that, again, this is a place where biology could be contributing to the differences between men and women at the academic level. So I bring all of this up and what Pinker is arguing here, because it still has a huge impact on the way that many academics think about these issues today. I mean, we are still struggling with trying to increase equality of representation between men and women in many fields that are represented at the university and in society in general. And so when people have discussions about this, it's important to understand that there are people like Pinker and Lawrence Summers and others who've made these sort of arguments that there are actual differences between men and women that can't be denied, that could be possibly due to biology, and that those are things that need to be considered as we develop policy. Just to give you another example, I remember a few years ago I was about to send my son, I think he was in year 4, and he was going to go to a robotics class that was going to happen after school. So it was sort of like this program where you could send your child to learn about robotics. And so I was excited, my son was excited to learn about robots. And so I showed up to the first meeting of the parents and their kids, and almost everybody there was, every child that was there was a boy. I think there was one girl and maybe 25 boys. And I knew that this had been advertised equally to parents of boys and girls, but only the boys were showing up to this robotics thing. And I think to this day, the robotics club at my son's school is still primarily a boys' club. And I remember being really frustrated at the time and talking to one of my colleagues about this and saying, what is it? Why are not these parents sending their girls to the robotics club? And my colleague said, hey, Eric, don't you get it? It's probably because of these differences between boys and girls' brains that explain this. And I couldn't help but think that, no, this has to do with socialization, that it has something to do with perhaps that these parents don't think of their girls as being, that this is a girls' kind of subject to go into. And so they don't encourage their girls to go try out the robotics class, even though they might actually enjoy it. And so therefore, you've already got this big differences happening at the grade 4 level. that maybe starts to carry them through all the way up through to the university when we get differences in engineering. That's just me. That's my particular perspective. But as you can see, others have these other arguments about the fact that they really do believe that there are differences between boys and girls' brains. My personal thing is that I align with what Neil deGrasse Tyson has said when he was asked about why is it that we don't see why do we see differences in, for instance, in boys and girls in interest in astronomy and physics. And they wanted to know, do you think that the brains are different for boys and girls? And he says, well, before we start talking about genetic differences, or he means biological differences there, you've got to come up with a system that has equal opportunity, and then we can have that conversation. So like Tyson, I agree that perhaps we're not actually at the place where boys and girls in school have equal opportunities or equal encouragements for these things, despite what Pinker said there about the fact that parents and teachers don't treat boys and girls differently. I still believe that there's probably some structural differences here that need to be dealt with first, that those are the most important, and then you could look to see whether or not there are any big contributions from biology. But like I said, it's an interesting source of controversy, an interesting source of discussion, and I don't by any means want to give you the definitive answer on this. I think this is something you need to grapple with yourself. Well, I want to go ahead and change the topic now and look at one other controversy that's been brewing in psychology in recent years. And what I like about this particular one is it kind of points out that you, a psychology student today, are living through, I think, a huge historical moment in the history of psychology, and what I consider a revolution in psychology, that things have been changing in just the last 5 to 6 years in psychology, and that as you came to study psychology at this particular time, you're in the midst of it. And I think probably a lot of you are now aware of this revolution in psychology. When I first talked about this a couple years ago to my students, most of them hadn't heard a thing about it. So let me go ahead and just talk a little bit about it from a historical perspective. So I'm going to go ahead and talk about some of the antecedents that led to this current crisis in psychology. And I have here, thanks to Andrew Gelman, who isn't actually in psychology, but has been blogging about the crisis for a while now, and he's got a lot of historical information up there. So one of the first people that I want to talk about that is kind of an antecedent is this psychologist, Paul Meehl, who really made some really interesting, profound contributions to the philosophy of psychology, and it was somebody who was actually really interested in some of those arguments that came from the Vienna Circle and the logical positivists, and how science should proceed. And so he was always, in his career as a psychologist, thinking about psychology as a science and what are our weaknesses and strengths and why do we do the things that we do. Anyway, he talked about this back in the 60s and 70s. He said, a zealous and clever investigator can slowly wend his way through a tenuous nomological network, performing a long series of related experiments which appear to the uncritical readers as a fine example of an integrated research program, without ever once refuting or corroborating so much as a single strand of the network. And so what he's trying to say here is that, in a way, what any good researcher could do, an effective researcher, is just present a body of research from their lab, from their line of research, that just kind of shows a clear path of experiments or other studies here that support their theory, their point of view. Think of Wundt, think of Tolman, think of any of the people we've covered this semester who had like a body of work and these experiments that they did. And it just looks like they never once had to refute or worry about any part of this. And he called this the find statistical significance any way you can and declare victory paradigm. That is, what it's saying is that you could just go ahead and only, you could be motivated to make sure that your findings are statistically significant. And once you do, then you can move on and declare victory that you were right. And so this means that statistical significance becomes the primary thing that we're focused on, that we want to show we have a significant effect. We haven't really talked about in this course how that came about, like why it is that in psychology we focus so much on p less than 0.05. But without getting into the history of that, we can at least acknowledge the fact that this becomes sort of the way that psychology has become, that we now really do focus on our statistical significance, and without it, you can't really declare victory. Jacob Cohen, a statistician in psychology, talked about this a lot too. Cohen studied statistical power, spreading the idea that design and data collection were central to good research in psychology, and he published this important book about statistical power analysis for the behavioral sciences. So he's the person who first really showed us that we had to be considering our power of our research in order to make good conclusions about our data. Now, here's some other important developments that I think you need to think about. In 2001, we have a young professor. She had actually just finished her PhD from Harvard, where she had published her research from her PhD in some major journals, then had been hired at the University of Texas as a new assistant professor. And in between the time that she had finished her PhD and she was now about to show up at the University of Texas, she was discovered to have faked some of her data. And so 3 papers that were published in a very prestigious journal, the Journal of Personality and Social Psychology, had to be retracted because she had completely faked her findings. She had just messed with the data to make it look like she had significant effects, and therefore got her papers published. So this is like one of the first times that we had somebody who was very public, who was like a rising star in psychology, who was brought down because of the fact that she had actually faked some of her data. Then in 2009, another interesting paper came out that kind of pointed out some of the problems of the way that psychology was going. And this one focused on the rise of neuroscience, and in particular, social neuroscience and its emphasis on doing fMRI research. So Vull, Harris, and Winkelman and Paschler published a paper that had been dubbed the Voodoo Correlations paper. And what they did is they reported on how there were a lot of statistical problems in neuroscience in the way that people were analyzing their fMRI data. And basically, it kind of goes back to the idea that Paul Meehl had, which is that, above all, you want statistical significance. So MRI researchers, with their very small, low-powered studies, had found a series of ways to analyze their data to yield findings that they could say were statistically significant. And what Vull et al. Argued in this paper is this had led to a lot of really bad studies being published in which it looked like through statistical jiggery that they had able to come up with some findings. Then in 2011, a lot of important things happened in 2011. Simmons et al. Published a paper called False Positive Psychology, Undisclosed Flexibility in Data Collection and Analysis Allows Presenting Anything as Significant. And this was a paper in the Journal of Psychological Science, and they introduced this term, researcher degrees of freedom. And we'll talk about researcher degrees of freedom in a little bit, but this is a first time that we get a paper that's really starting to bring up some of the current problems that we have. Another thing that happened, though, in 2011 was that Daryl Bem, a famous social psychologist, published a 9-study ESP paper in JPSP. And you remember the origins of ESP research back at Duke University in the 1930s. Well, Daryl Bem was now a prominent psychologist in his university, I think it was at Cornell. And he, for a while, had been really interested in ESP and had come up with experiments, so very much like those ones done at Duke. And overall, he argued that he had found evidence for ESP and got it published in one of our top journals, JPSP. And when he published this paper, there was a lot of immediate skepticism saying, come on, ESP isn't real. There's something wrong with these studies. And the editor responded by saying, well, 4 reviewers made comments on the manuscripts, and these are very trusted people. And the paper got published. And then the other thing that happened in 2011 was that we had more episodes of misconduct reported, like the ones that happened with Karen Ruggiero, where Dietrich Stoppel at Tilburg University was found to have, again, faked a lot of data. That Mark Hauser at Harvard University had faked a lot of data, and both of those people lost their jobs. So this was quite a key year, just 2011, where we have a lot of uproar going on in psychology and making people question where we're going in the field. So what happened in 2011 to 2015 is that our field of psychology started paying more attention to this, and you can see important blogs that are then started, new ways for people to communicate and discuss these things, like Neuroskeptic, Andrew Gelman's at Columbia, Retraction Watch. And then you also get the Center for Open Science and the Open Science Framework software projects are started. This all happened during that time period. And people start reporting papers in which they fail to replicate noteworthy studies. And so now more papers coming out during this time period showing us that once famous studies that seem to be above reproach, people now attempting to replicate them can't replicate them. So that leaves us then to this question. What exactly then is the crisis? What would you say is really the problem that's been uncovered in these last few years? Well, one answer, and this goes back to that Simmons et al. Paper that was published in 2011, is that we have a proliferation of what they call in that paper of false positives. That false positives, where you reject the null hypothesis when we shouldn't, are a costly error, because once they appear in the literature, they are particularly persistent. So if you say you had a significant effect, but it turns out you really didn't have one, it's a null result, then when somebody else tries to replicate it and only gets a null result, it's hard to get that null result paper published because it failed to replicate. False positives are also a waste of our resources. We have maybe fruitless research programs out there, students trying to do a thesis where they're following up on some study, and if it was really just a false positive in the first place, they're not going to find anything. And maybe also we'll get ineffective policy changes. And if there's a lot of these false positives, then the field is going to start to lose credibility. In psychology, even though we have a nominal false positive rate of less than 5%, so that's what we say when we say P is less than 0.05, they say, well, we have these research degrees of freedom that increase the rate, that we try to manipulate our analyses and do things to it so that we actually get significant results. And this again goes back to Paul Meehl. We want to have this record of success, this steady pattern across all of our studies that show that our theory or our big hypothesis or whatever it is that we're trying to get out there is significant. We do what we can using these researcher degrees of freedom to increase that rate above 0.05. So you could say, well, does that really happen? And one of the ways that we can see it really happens is by doing what's called a P-curve analysis. And Daniel Lakens first started talking about this in 2014. He looked at the p-values of studies that have examined things like the elderly prime effect, where this is a phenomenon in social cognition where you can activate a stereotype of the elderly and then make your participants move more slowly. So you make people think about old people, and then you ask them to walk away, and when they walk away, they walk more slowly than if they didn't have that stereotype. And then there's also something called the professor prime effect, where you can activate the stereotype of professors, and this will make people work harder and perform better on tasks. And an example of this is Diesterhouse and Van Nippenberg in 1998. And so what Lakens did is he took 18 p-values from 17 studies that had been done on the elderly priming effect in 8 different articles, and he plotted them and said how many of them are at p less than 0.01, how many of them are 0.02, 0.03, 0.04, 0.05, and so that's the dark line there. And you can see that most of the p-values, the 44% of them, are actually at the 0.05 level. Very few of them are at 0.03, 0.02, 0.01. So those numbers above the black line are the percentage of p-values that had those particular p-values. The problem with that is that if you just take a modeling of what p-values should be like naturally occurring in the world, and you have 33% power to detect a real phenomenon, you should in fact get more p-values just by chance that are at the small end of the continuum, that are at 0.01 or 0.02. Very few should be at the 0.05 level if you have a real effect. But you can see across these studies that, in fact, researchers are giving us a lot of p-values that are just below 0.05. And that is a bit suspicious. That tells us that perhaps the people are hacking away at their p-values to get them just below 0.05 so they can get their papers accepted. So perhaps these are a lot of false positives on the elderly priming effect. Just by contrast, looking at this other literature on the professor priming effect, you can see that when you look at their p-values across 8 articles, these are 16 studies, that about half of the p-values were around 0.01, only about 5% were just around the 0.05 level. And this follows a better model of what you would normally expect for p-values. So this particular group of studies doesn't look like it's been p-hacked. It doesn't look like people were using researcher degrees of freedom to do this. He says here in Lakens that most likely they overestimated the effect size of R.36 at the minimal sample of size to achieve a statistical power of 0.8 would require 28 participants in each between subjects condition. The average sample size in each between subject condition and the reviewed studies was 24, and 6 of the performed experiments had sufficient power to detect an effect of R equals 0.36. What he's saying here is that in this group of studies, the ones in the elderly priming effect, that the problem was they really were not testing very many participants. They had low statistical power. Even though Jacob Cohen decades ago wrote about how much statistical power we have to have in our studies and how you get to it, researchers are actually conducting the research with too few participants to help them detect real findings there with that kind of power. And so this, again, maybe is the explanation about why people are involved in doing things where they mess around with their statistics enough so they get just below 0.05 because they didn't really have the power in the first place to get the findings. So they have to kind of use these questionable practices to get to that. So I call them, instead of researchers' degrees of freedom, I focus on this thing called QRPs, or questionable research practices. And so some of the ones that have been pointed out in recent years are that maybe in psychology we're using too many small sample sizes. Researchers typically overestimate their study's power and underestimate the sample size they need to obtain just a 0.8 power with a small effect size. You can see this in this article by Backer et al. That was published in 2016, where they asked psychology researchers about how much power they think they need. So you say to the researchers, typically, you say to them, how do you actually figure out the sample sizes for studies? And the answers that they got in a survey of psychology research was, well, practical constraints. So a lot of people say they just test as many as feasible, given their practical constraints that they have in their research. Some of them just choose a rule of thumb, like maybe it was taught to them, they should always have 20 people per condition. A lot of people say, well, this is just the way it is. It's a common practice in developmental psychology that we test 10 babies in each condition. So they just saying this is what our common practice is. And others just say, well, I just want to collect as much data as possible. We just test as many people as we can until we just wear out, we run out of resources or whatever. You'll notice that none of these answers are really focused on statistical explanations. No one's actually saying that they picked their sample size based on Cohen's work on power. And so if you look at just a 2-condition experiment, if you had a control and an experimental condition, and you talked about power of 0.8, which is what the recommended power should be in a study, although some people are now going up to 0.9 or 0.95, that really, if you have an effect there and you have a small effect, a medium effect, or a very large effect size, that if you have a small effect and you're looking for a power of 0.8, you're going to need 788 participants to notice a small effect, just in a 2-condition experiment. When you ask researchers what they think they need, they say, well, you only need 216 people when you have a small effect. So they really greatly underestimate the number of participants they really need if they have a small effect size. If they have a medium effect size, you can see they do better here. That is, if you have a pretty good sizable effect from your independent variable or whatever it is that you're comparing, you're going to need about 128 participants, 64 in each condition. That's pretty close to what the psychology researchers in this study estimated it to be. And if you have a very large effect size, researchers tended to overestimate the number that you need, because there you can get by actually with 26 people per condition. I think the real problem is that probably a lot of our research is on that small to medium size. And that a lot of us are way too optimistic about our effects being in the medium to high or to large size. The bottom line then, though, should be that you should aim for at least 60 participants per condition if you want to assume a medium effect size and have power to be at 0.8. If you're going to increase your power to what now people are recommending, you're going to even need more participants. If you have a smaller effect size that you want to assume, you're going to even need many more participants. Another questionable research practice is that we have selective reporting or partial publication of our data. So the issue here is that a lot of people conduct many analyses and then only pick out the analyses that support their hypotheses or have significant effects, and then don't refer or mention the other measures, the other analyses where they didn't have effects. This again goes back to Paul Meehl and saying, we like to have this perfect looking record of accomplishments and victories as we conducted our research. And so you can just cherry pick through your results to support the things that fit your hypotheses, which you wrote about in the introduction, and not report everything that you actually did. Another problem is what's called optional stopping. And this is the idea that researchers collect their data until they get a significant result. So they just keep checking. They go ahead and test a certain number of participants, then check to see if they got a significant effect. They say, no, can't do that. So they go ahead and collect some more data. The main reason why people do that probably is because they're trying to conserve their resources. So maybe it costs a lot of money to test participants. And so in order to keep the costs down, they try to run as few people as possible, run the analyses, then see if they have a significant effect. And if they don't, go ahead and collect some more data. The problem with this is this also inflates your type 1 error. And I can't get into it right now, but Simmons et al. Talks about it in their article that basically every time you do this, you end up, if you took that dotted red line there, that's the p.05 level, you actually are inflating the chances that you're going to get a false positive by running more people every time you find a non-significant effect and then testing them again and seeing if you get an effect. You're just by chance more likely to get a false positive then. We have this problem of p-value rounding, where people do things like take their p less than 0.05, right? But let's say they've got a p-value of 0.051 or 0.6 or 0.65, and what they do is they round it down so it's below 0.05. And there is a way of dealing with this now. It's called stat check, where you can take this particular software, feed through a manuscript to it or someone's article, and check the p-values to see if indeed those p-values are really what they say they are because of rounding errors. So this is a way to check your own work to make sure you haven't done it, but also to check other people to see if they maybe have been rounding their p-values just to make sure they look like they have a statistical effect when they don't. Another questionable research practice we have is the file drawer effect. And this has to do with the fact that our field of psychology is really so focused on positive results that we end up not reporting our null results. And so it could be that we hide a lot of our studies that didn't work out. They don't get published. We also have this problem of what's called post-hoc storytelling. It's also known as hypothesizing after the results are known. What's happening here is that a lot of researchers take their findings after their analyses and discover that things are more complicated than what they originally hypothesized, or maybe even their findings are wrong. They don't support their hypotheses, or that the logic that led to this experiment was wrong. And so they don't want to look like they were wrong the whole time. They don't want to look like they have a opposite result of what they predict. So what they do is they go back and change their story. They change the introduction so that it fits with what the results actually are. And so then we have a better story. That's what the story is, right? So this is a questionable practice that's been around. We've known about this for quite a long time. Norbert Carr actually talked about this back in 1998, that he called it harking back then. In fact, a lot of psychologists have been told by their supervisors or been trained that they should have a good story and that they should engage in harking, despite the problems that this would have. Because again, it inflates what looks like possibly type 1 errors, false positives, making it look like we have findings when we really don't have them because maybe it was just by chance. So even though you didn't have good theoretical reasons to have this null result, you've changed it to make it look like it did. And so therefore you're propagating perhaps a null effect, or a false positive. Another questionable research practice that people have found is the manipulation of outliers. And what this means is that people do things with the outliers in their data, include them, not include them, change the cutoffs until they get the significant result that they want. And just an example of this, Simmons et al. Looked at in their 2011 paper how 30 psychological science articles had reported reaction times. And keep in mind, all of these are just fairly simple cognitive experiments where people have to press a button really fast to some stimulus. And they looked at how people decided whether or not their reaction times were too fast. And what they found in these 30 articles was that some people used the cutoff of the fastest 2.5%, some used 2 standard deviations from the mean, some said that anything that was faster than 100 or 150 or 200 or 300 milliseconds was too fast. When you look at the too slow responses, people in these articles mentioned things like they got rid of the slowest 2.5% or the slowest 10%, or they use 2 or 2.5 or 3 standard deviations slower than the mean, or 1.5 standard deviations slower than that conditions mean, or they use cutoffs of like 1,000, 1,200, 1,500, 2,000, 3,000, or 5,000 milliseconds. Why I show all that up is just to show you that something as fairly straightforward as what a reaction time is, that we get this wide variety of practices about determining what's an outlier, what should be excluded as too fast or too slow. And what Simmons and all want to suggest here is that the reason maybe why there's all this variability here is that the researchers are changing the cutoffs while they're analyzing their data to give them the best results. So maybe they found that if they use 5,000 milliseconds is too slow, then they got results that supported their hypotheses. But if they only used 1,200 as their cutoff, it didn't. And so this is a problem if people are picking and doing things with their outliers and not staking what they're going to say what the outliers are going to be before they actually conduct the research. They're going to wait to see what the effects are on their analyses. Then again, they could possibly be going for that just below 0.05 effect, and we're going to get more false positives. So here are all of these questionable research practices all done at once. We use small sample sizes, selective reporting or partial publication of our data, optional stopping, p-value rounding, file drawer effect, post-hoc storytelling, and the manipulation of outliers. And the bigger problem then is that the cumulative effect of all of these QRPs is that perhaps then our published findings in psychology are much stronger than they actually are, which then led to this bombshell of a paper that came out in August of 2015 that was published in Science. And you can see it's published by many authors, called the Open Science Collaboration. And this is considered another sign that we are indeed or have been in a crisis here in psychology. What happened here was that they took 100 studies that had been published in some of the very top journals in psychology in recent years and had different teams around the globe try to replicate that study as best as they could. They tried to contact the original author. They tried to use exactly the same stimulus materials. And then they conducted the study and they looked to see whether or not it had been replicated. And what they found was that only 39% of the original 100 studies could be replicated, and in terms of giving them significant results. And you can see that here, that the greenish, bluish aqua bar circles here are the ones that were replicated. All the other ones were not replicated. They weren't significant. And it has something to do with perhaps the original effect size, that if the original study had a bigger effect size, you saw more studies being replicated there. Although there are plenty of studies that had large original effect sizes that weren't replicated in the replication project. But still, the overall bottom line is that only 39% of these replicated studies had significant results. They looked at a lot of different characteristics of these studies to try to understand whether or not a study could be replicated. And there are different things here. One of the things that you could predict is that the surprisingness of the original result, that is, if you went back and looked at the article where that study was originally presented, and you asked judges who know about the field to say, how surprising do you think that result was at that particular time? You could see that that actually was negatively correlated with whether or not the study now replicated. So the more surprising the original study was, the less likely it was to replicate in this replication project, which maybe tells us again that the original study had a false positive. Maybe it wasn't really something that you would have thought from theory should have happened, and because it was something that was so unexpected, that's in fact why it got published. Maybe the journal liked it because it was such a novel finding, but those turn out to be more likely to be the studies that don't replicate when you try one of these replication projects. There's been criticisms of the project itself that was published in Science. You can see Gilbert and his colleagues talked about the fact that they thought there were a lot of problems in the way this project was done, and they go ahead and argue that there's lots of statistical errors. But then there was a comment back to Gilbert and his colleagues, and they say, no, we did take into account all these statistical problems that you're saying that we have, and they very nicely go through and deal with them. So there's been pushback. What I'm trying to say is that when that article came out that showed only 39% of the studies replicated, there's been a lot of symposia, conferences, papers attacking the original replicability project and trying to find problems with it. And then the people behind that project have pushed back and said, no, here's some things we can show you. All of our analyses, all of our methods are actually freely available. They're all open. You can look at them yourself. I just want to point out that this crisis sometimes has been viewed as just a crisis that was limited to social psychology, because a lot of these experiments that didn't replicate were social psychology experiments. And some of the people who read these replication studies were actually social psychologists. It's not just limited to social psychology. For instance, there's another paper that was published here in 2013 in Nature Reviews Neuroscience, in which the authors of this paper were arguing that neuroscience has this problem as well. And you remember this goes back to that voodoo correlations study that argued that maybe there's a lot of statistical jiggery going on in the way that people are analyzing neuroscience data because it's really low powered. What Button et al. Argued in this paper was that neuroscience studies, for many reasons, end up being really underpowered. So if you look there at the right where it says 81 to 90, that should be the kind of power that you would expect in a study. Remember I said the normal standard is 0.8 or 80% for power. And very few studies in this analysis that they were going at here actually showed that studies were powered at 0.8 or higher. In fact, most studies have much lower power than that in neuroscience. The reason why that happens in neuroscience, of course, is because the methods are so expensive. It's expensive to do an fMRI scan. It's expensive or difficult to use animals to do dissections or do other kinds of things. So they do tend to have small samples, but statistically that means then they have low power, and therefore they're probably less likely to get a significant effect if they want to get them published. So perhaps, again, they're getting themselves engaged in a lot of statistical jiggery or questionable research practices. One of the things that the authors of the Button et al. Article paper argue is that perhaps what researchers need to do in neuroscience is work more collaboratively to increase their power and to replicate their findings. And even hormone research is sort of suspect. This is a paper that was published in 2016 by a friend of mine, and you can see here that they looked at oxytocin studies and found that intranasal oxytocin studies are generally underpowered, and that one of the reasons why we have this wide variety of effects of oxytocin on behavior, you might have heard of it, this is like the love drug or something, is that perhaps, again, the problem is that our studies in oxytocin are generally underpowered. We have too few participants, and so there might be a lot of false positives going on. So I'm going to leave it there, because next week what I'll do in the next lecture is talk about the way out of this crisis and how things are tending to get resolved now. And so some of this, I think, is relevant to today, because we're kind of moving through this historical revolution in psychology, and some new things are coming out of it that I think are quite positive. And so I'll save that to the next lecture.